I'm Boris Weissman. I'm a co-founder, chief architect of Datrium. Last 2 years, that was my project. And Mike?
Yeah, Mike McLaughlin, head up tech marketing. I'm going to be driving from this side, and at the moment here, I'm going to rearrange some screens so we get into a live demo of the product, and then we're going to kind of tag team here a little bit of the details, the demo, the details, the demos, the questions. Okay?
Right. That would be an opportunity to ask more questions after you see a segment, so we should be fairly prepared. And while this is going on, maybe I can pick up that question that you asked. How true is that zero RTO? As everything else in life, it's a trade-off. If you're willing to pay a little bit of money, you can have true zero RTO. For example, you don't have to pay $1 million for 16-node SDDC deployed. You can have a single node SDDC deployed for what's VMware charging these days, $50,000.
Hang on that. You said a zero node, a single node.
You could.
You can only have it for 30 days.
Well, yes, but we're not doing anything with it. So as you'll see in the demo, we're just trying to skip that particular time to spin it up. So we will just, if all you want is to get to zero RTO, we just need it there. We don't keep any infrastructure on it. We don't need anything on it. We just want to skip that latency that VMware has for creation of SDDC. And those of you who have played it, most of that latency goes into copying the management infrastructure virtual machines.
I guess on that point, because you're not starting with anything,
right?
When you fail over, you can spin up that one node for 30. Because if it's just for a DR test or you're failing over 10 VMs or whatever, you can start from one. And as long as you fail back,
and then it takes 6 minutes to add additional nodes. So you have a range of cold, which is 30 minutes to 90 minutes, depending on the geometry and shape, to completely zero, where you pay a lot of money up front, to something in between, where you pay a little bit of money, you get mostly zero RTO, but it's a little bit less convenient. So we support a full range, cold, warm, hot. Mike?
Okay. All right. So we are live in my view of a hybrid multi-cloud VMware world. All right. I'm going to play the role of administrator and user here briefly. On the left-hand side, I'm VPN'd back into my private data center, just down the road in Sunnyvale, running an on-prem DVX with a number of things set up here. One of these happens to be a little Cloud Field Day demo where obviously we're looking at CloudShift. All right, so that's just a live environment running there. On the right-hand side, I'm in the public cloud. This is VMC in AWS. All right, so when we're talking about operational consistency from an administration perspective, this is my world. All right, as an administrator, I'm looking at VMware in 2 different environments, an on-prem private cloud and a public cloud environment. And all of the operations familiarity tools that I have are available for me. Now, this is a fairly short little demo. We're going to deep dive and then come back into some of the real details. But just sort of like a movie trailer, I want to kind of go here and say, what happens to the user when disaster strikes or something? All right? So my customers, my users that are working off of my environment, I just shut this down. This will go, it goes away. All right? And I get the call. Can you get me back up and running? And if the primary site is down, I'm going to use our CloudShift product. Now, I've already clicked through a couple of things here. We'll get back to the details in a minute, but I'm going to go ahead and click Finish on the failover here. And what's going to happen relatively quickly here is it's going to begin executing the plan that I created earlier. We're going to get into plan details in just a minute, but the virtual machines are being recovered in the cloud on the VMC, and they should show up in this users folder here. If I click over here. So here's my Cloud Field Day demo virtual machine coming, and it just came alive for me. So if I was servicing that user, I'd say, hang on a second, your work is here. That virtual machine that he was running on-prem just shifted through Cloud DVX to VMC on the cloud. All right? And it's going to take just a couple of minutes to finish up, and we'll come back and look at the details behind that. But that's the idea of what we're trying to do. Operational consistency between 2 different worlds. All right?
Finally.
Now, the devil's in the details. So let's go back to here.
Okay, thanks, Mike. Just to rehash, So Mike's original virtual machine was running on top of on-prem DVX, and as we pointed out before, we are a full-service company. You can buy hardware from us, you can buy software from us, you can buy storage from us, and there is a lot to keep in mind here. There is 4 components. There is private cloud. In this demo, it is Datrium, the entire setup. We also have replication to the cloud, so that's the data ends up eventually in S3. To get there, it has to go through our virtualized file system running on AWS. But essentially, you're paying for S3, and data is in its most concise form. The replication is forever incremental, globally deduped. Data ends up in its compressed, native, deduplicated format. There is no data hydration anywhere because we control everything. In fact, the only time data hydration happens in this demo is when the VM is actually powered on. And then, of course, there is a VMware part as DDC that we use for operational consistency. Very quickly, so the site goes away. So we have a global orchestrator that can recover VMs either to another on-prem system or today, since it's Cloudfield Day, to the cloud. Just very high-level view. Now we'll get into details, and I'm sure you'll get a lot of questions. Service activation, I think somebody asked about it. So how does it all work? What do your customers want? We have been observing this field for a while, and we see a variety of opinions. Some customers just want ease of use. They don't even want to provision LWS or any other account. They just want us to be a single point of contact and support, and we support that mode of operation. So this is true SaaS, where we take ownership of the data and orchestration, everything else. The other extreme is larger enterprises who embrace the cloud, but they also embrace it with constraints, where they have system administrators who want to impose restrictions, how data is accessed. And in that case, they can bring their own accounts to us. Either way, so the experience is very, very similar. You have to register your accounts with us, and that's pretty much it. For this demo, there are 3 services that are enabled. There's a cloud backup service. You can use it independently. And there was a question about that. You can just use cloud backup and restore on-prem if you like. There is a cloud orchestration service for mass restart, either on-prem or in the cloud. And there is VMC, which is also a separate service, right? And at the end, all of these are enabled within a minute or so. You just bring your credentials, and we stitch together the entire system. And what happens, obviously, there is a lot behind this simplicity. So, for example, if the customer decides to bring their own AWS account, so what happens is that they bring their credentials to us, and we already publish everything necessary to bootstrap the service in AWS. So we have our AMIs, and we also use Lambda extensively. Those are already published. And when the customer comes in, we make these services available to their account. So we create the role in AWS, which, and this is what the Lambda will assume, which makes it possible for the Lambda to actually instantiate AMI images into a customer account and provide other services. And also, to make sure we are completely secure, we create our own VPC inside AWS. And given that we are constantly developing more and more services, they all go into that VPC. So the Lambda creates a VPC. It also creates a subnet. It establishes routes in the subnet. And once all of that is set up, then the Lambda function actually goes off and instantiates the AMI image for the CloudShift service inside the customer environment. Now, at that point, so we are still in this activation stage, and CloudShift AMI takes over. Instance at this time takes over the completion of the activation, and it uses a couple of other services such as DynamoDB in a lightweight way for service registration, etc. To get to it, you need to create an endpoint. You need to wire it up. So it basically completes all of this automatically, and Aurora. So for transactional operations, we actually rely on the transactional database provided by AWS service, right? And that is highly available, replicated 6 ways across several availability zones, needs to be provisioned, needs to be wired up. So that's also happening magically. And so at that point, CloudShift service is running, but for this demo, we also need a backup in the cloud, and that's a second service that gets deployed. And similar motion, so Lambda knows what is a desired configuration state, what are the services that the customer activated. It goes off and instantiates our backup service. And in a similar fashion, because everything in S3, well, you have to get to that S3, so you need an endpoint. So you have to create an endpoint, and you have to wire it up, make sure it's accessible into that VPC inside that subnet. And we are almost done, but not quite yet, because you still need to back up from on-prem and into the cloud. And we decided that for simplicity, to actually provide our own VPN, so the customer doesn't necessarily have to go and acquire VPN from AWS or subscribe to Direct Connect, which are very valuable but expensive services. So we just provide our own VPN, which we also instantiate. And this, when this is all done, now you have the ability to transparently back up into S3, right? So that's just the backup part. So before Mike killed his virtual machine, it was running, and it was magically backed up into S3, made possible by all this infrastructure running in the background.
Is that infrastructure, is that a customer's AWS account?
It could be a customer account, it could be ours. So we have two models.
You have the two models.
We have two models, right? Even if it's our account, we separate them by customers anyway. So in the it's very, very similar software infrastructure.
In the option where I'm doing the customer account,
yes.
Do I have to use the Datrium VPN, or can I?
Today you have to use Datrium VPN. We might have to rely. The VPN, not VPC. No, so all right. So Datrium VPN, if you have Direct Connect, obviously, and you have guaranteed bandwidth, great. Not all of our customers are in that position.
No, but if I want to deploy it in my own account. But then again, I guess extend that further in terms of subnets and things like that, I may already, I'm
right. So today we will insist on keeping track of all of that ourselves, and you have to give us privilege to create a VPC and a subnet. We might have to open it up in the future because we have come across requirements where the system administrators were reluctant. But in the common case, that seems to be okay for now.
Yeah, I mean, I could give you a chunk and you could manage it. So I understand that. But yeah, as long as I've got the option of a VPN, I understand you're trying to simplify those pieces. But if I've already got connectivity and reliability, especially if I'm shipping backup data over there, that's fine. Okay, cool.
So it's another trade-off. So if you can supply your own VPC and a subnet, it's more configuration. So in some cases, you want to hide it completely. But yes, so that's something we'll have to deal with.
Sorry, just on that,
Sure.
I can't even give you my VPC. So I can give you a Direct Connect, but then I would give you an endpoint into that.
You would give me an endpoint into that, but to instantiate anything, to instantiate an AMI, I need some kind of a VPC and a subnet. So if I'm not creating it, it has to come from an organization, right? Because that's required.
Is it a subnet you need, or a full VPC?
So right now we need our own VPC, but obviously that's not a requirement. So at the end of the day, we'll be happy with the subnet. By the way, VMC also requires that, because VMC, and we'll get to that point, when VMware creates the SDDC, it basically looks like a block of IP addresses inside of subnet. It's very similar kind of motion, right? And we'll have more slides of that. So if you have any more questions, be happy to answer them. So after this is all set up, so the Lambda keeps running, and
just one more question before we get off that. Single AZ or?
Oh, no. So right, I'm getting to that point.
Oh, okay.
So initially we bootstrap in a single AZ. Lambda takes over, and it assumes monitoring and healing functions. And basically all of that infrastructure we deployed, so we have a directory of services, so it knows what should be running. If something is wrong with an AZ or with some parts of it, so Lambda knows how to redeploy all of that in another AZ if necessary, right? So all the data, persistent data is replicated. So single AZ going away, we're not going to lose anything. So we do support multiple AZs. Okay, so this is just normal operation, but then, what do I do if something bad happens and, my on-prem data center goes away? that was just AWS, right? So we have our legs in 3 places. We have AWS, we have on-prem, we have VMware. So this is where we get into all of these SDDC deployment questions. You have 3 options. There's a cheap option, but it doesn't cost you anything until disaster happens. And we fully automate provisioning of SDDC. It will map, it will work with your subnets and everything. And you just have to deploy it. You push the button, it will be deployed and automatically wired up into your account. So you guys are coming from VMware, so you know this is a completely different world, right? So whatever AWS has, VMware has its own take on pretty much everything, on networking, on storage, on security. And what we wanted to do from the beginning was to shield our customers from having to learn anything new. So your building is on fire, right? It's a disaster. It's no time to read a 300-page VPC manual or a 1,000-page NSX manual, right? So we deploy the infrastructure for you, and we wire up networking on both sides because they both control their firewalls in different ways. And to do instant restart, you have to make sure you can reach to S3 from inside of VMware. You also have to make sure you can reach to Cloud DVX from inside of VMware and vice versa. And at the end of it, we inject an NFS proxy VM. Essentially, it's a virtual machine, vSphere virtual machine, not AWS, that normally lives inside of our AMI image, amusingly. And then we inject it into vSphere, and it presents backups through an NFS data store interface, right? So, and why do we do it? Well, this is the sort of thing that gives you instant restart. So as far as SDDC is concerned, suddenly there is this new external data store that presents point-in-time backups going back 7 years, if you like. They happen to be backed by S3, but to VMware, it just looks like, just files that you can execute. And let's see. And because of that, we can just spin up VMs without any data copy. They can just start up immediately. Let's see. Of course, on top of it, you need performance, right? And so the weak point of this whole thing is today, the bottleneck is a connection between SDDC and S3 or anywhere else, right? It's not bad. You can get up to 500 megabytes a second, but that's all you can get today. Now, given you have hundreds of terabytes potentially, so that might become a bottleneck. So what we did was we moved some parts of the file system inside of that NFS VM right there. So we have local flash caching and deduplication there. So we don't take this link until absolutely necessary. And given that we normally see data reduction rates due to compression and deduplication, as Sadala pointed, say around 4, essentially that physical bandwidth gets amplified by the same factor, right? So that's one way.
Sorry, I have a question.
Go ahead.
I didn't think third-party data stores were supported in VMware Cloud yet.
Say it again, sorry?
Third-party data stores are not supported yet.
It's supported for partners. So it's
not yet, not until the next.
So it's a pre-release form. They enabled it. This was live demo.
It's a pre-release, yes.
Yes,
but
we cannot
I
resell
can't
it
buy
today. That's correct. So this is a technology preview. Yes.
But that could be up until the Gen 8 VMC.
So right. So I mean, obviously we cannot. We are working with them. We have been their partner for 5 years. Obviously they have their schedules. We have ours. It worked great for us. We have been using it to develop the product for since the beginning. It's true that they need to productize it fully for us to be able to sell the product, make it available. But yeah, absolutely true.
Given that this is network storage, and I'm assuming it's going over the transit gateway to allow the connectivity and everything.
It doesn't. It stays. So they have a direct pipe to S3. It doesn't go to the internet.
Okay. So what kind of latency and IOPS are you able to achieve?
Right. Very good question. So we are in this state transiently. I'll answer your question, but basically, if it's a real failover, not just a test, so we have an orchestration solution that migrates your workloads after they boot up and get going onto a vSAN data store, which is all flash and VME. So now, obviously, you're running off S3. You will not get exact same performance, as you would get from local NVMe devices. But that being said, this is in part why we have our cache and prefetching infrastructure there. So it would appear to the end customer very similar to a hybrid array. It's not as good as vSAN and NVMe, but one of those things could do 50,000 IOPS. And as far as streaming performance, we will top out very close to the physical limits in raw throughput, say 400 or 500. Of course, on top of it, there is data reduction. But yeah, so we understand that, and you'll see it in the demo, once VMs come up, we will automatically migrate them so that if you are to stay in that mode for, I don't know, a month, then you'll use the full power of vSAN and NVMe storage.
Given that Cloud DVX can mount S3 and DVX on-prem presents as an NFS mount point, why do you call that an NFS VM rather than Cloud DVX when it's running on top of, what's the difference there?
Oh, it's a very, very good question. So in a way, there is not much difference. It's repackaging of software that you would normally use on-prem. It's just that it's running on a virtual machine. And it's perhaps not the best naming on our part, but the reason we kind of give it a separate name, this is AWS AMI, this is a vSphere virtual machine. The software we haven't really changed. It's the same software that is running on-prem on the appliance. Perhaps we could come up with a better name for it.
Yeah, just slightly, yeah.
And it's just the top part of the file system. There were pretty much zero changes.
Yeah, you're not just bringing up some other NFS service or something at the
It's the top part of our file system. Yeah.
So who is managing that NFS VM?
We do.
You are managing it.
So the customer doesn't need to know it exists. So we'll show you. We deploy it. So it's full. Everything here is managed by us. So our customers don't need to know about any of this. So we're just showing what's under the hood. They don't even have to own the account, right? In the full SaaS offering, they don't even. It's just for you to explain how it's all put together.
Make this full screen so it all fits in a little bit better. So what I want to do is go back in time a little bit to before the disaster. We're going to talk a little bit about the on-prem DVX and the components and the things that we leveraged to get that capability to shift over to the public cloud. All right. So this is that original place where we were starting, where I'd powered off the machine. And I've built this environment already to kind of explain how the parts work together. All right, think of this as my private data center. I've organized my environment into a number of components here, of applications, databases, let's say infrastructure VMs, things that might be of interest. All right, to give you an idea of a little bit larger full-scale demo. All right, and I've set up my protection groups. So I went back to day one DVX, and I'm running my primary workload on-prem, building around my virtual machines and organizing them, but I'm also protecting them on that on-prem site with protection groups and all of these policies here. So I have policies for my infrastructure, my applications and databases, and I'm also replicating those actually to another on-prem site and off to a cloud DVX. So as I'm setting up SLAs for those recovery points, snapshots are being taken, kept locally, replicated either to the cloud or another site, depending on how you want to set that up. But in this case, they're going off to cloud DVX. All right, those are going to create snapshot point in time so that I'll be able to leverage for my failover. All right, this is a kind of a fundamental part of the on-prem DVX of managing some of those things that Zaro was talking about of the primary storage and the data protection and a number of other things. We're not going to deep dive into the DVX itself. I want to still stay at the CloudShift sort of VMware to VMware management capability. Now, one of the other things that I did, and back to sort of software as a service, is, excuse me, I took my on-prem DVX, I got my AWS account, I came in here and registered that, all right, and then I also built actually a couple of cloud DVXs. I have multiple ones. I get a little paranoid. So I have multiple locations out in AWS where I'm backing up my on-prem systems. But then I also, with a couple of clicks, deployed CloudShift, which is a lot of those details that Boris just showed you, a software as a service mechanism off in Amazon, in AWS, that was literally just a few clicks through here with having my AWS credentials and setting it up through the DVX. What that got me was another option here for my on-prem DVX to connect to CloudShift. All right? So the deployment of this into an existing on-prem site that's running on primary storage and protecting itself with our built-in capabilities is now connected off to the cloud. When I click on that, it takes me off to this screen. Now, this is the top-level view. All right, I was already down several clicks in that first demo. What this is showing me is all of the sites that are registered. So here's my couple of on-prem, the ones with the little buildings in it. I've got 3 different on-prem sites, 2 different cloud DVXs, and one of those is actually attached to an already provisioned SDDC. All right, I don't want to go through the provisioning process here. It's fairly straightforward. A couple of naming choices, a couple of clicks. Step away for a minute, it deploys, and then it's ready to operate in. So back to the RTO, if I have one running, and then in this case, this is just a single host SDDC, the way that was set up was, again, from my role as a VM administrator running on DVX, I came in my CloudShift environment, and I registered my VMC account with my AWS DVX relationship, and then I deployed an SDDC. All right, if I wanted to deploy another one, I have that other spare Cloud DVX out there. I could begin filling this in, and it would spin up another SDDC. That might take 45 minutes. I don't know. It depends on the current provisioning rate and what I decide to build. We're not going to do that now. We're going to use the existing one. But it literally is stitching this together with a couple of mouse, because we're doing all of the work behind that fairly complex diagram of parts that Boris just showed you a few minutes ago. All right. Now, once I have my on-prem and my cloud connected and I've got CloudShift sitting there, what do I do with that? All right. The thing that I showed you in that first very short demo was an execution of a plan. It was actually this VMC demo plan that we ran there. All right. You can see that failover committed, and it went from prod to cloud DVX. It was just a very simple, let's just show how it works. I want to dig into something a little bit more complex with some of the choices and some of the things that the VMware administrator, the site administrator, has to deal with when they're looking at this hybrid multi-cloud VMware world. All right, remember, I'm still thinking about things with an on-prem vCenter and a cloud vCenter. All right, so let's take a look at this plan right here. First thing is, I see a nice green check mark here. This is actually probably run twice since we've been here. So continuously in the background, CloudShift is looking down into the sites that are registered and looking at the rules and the plans that I set up to make sure that a plan that I defined on Monday and administration changes that I made to my sites on Tuesday, Wednesday, or even this morning are still consistent with the plan being consistent. All right? We'll look at that in a little bit detail later, but the green check means proceed and keep looking, or the plan is ready to either test or fail over too. What I want to do is just take a moment and look at what this plan means. All right, so as an administrator, it's a fairly simple set of things that I've got to put together based on my on-prem DVX and my VMC public cloud data center that I'm looking at. Again, think about operational consistency. Think about the things that I have to worry about every day as an administrator that are simplified because a lot of the work behind the scenes and all of those parts in AWS and VMC and even in my on-prem have been taken care of for me. All right, so real quick step through. We have 3 different kinds of plans. Tushar talked about that. All right, we can fail over prem to prem, not a problem. What we're looking at today is an on-prem failover to VMC in the cloud, and I can also fail back from my cloud DVX back on site if I want to. All right, so the CloudShift gives me the ability to move things around in my on-prem and public cloud instances. All right, we're going to look at this one. Clicking through, this is essentially my prod data center. That's what I called my primary on-prem, to my cloud DR. And I'm going to go ahead and choose to run tests directly in SDDC in AWS. Now, this is the critical part here. All right, we're building this off of the technology that is fundamental in the DVX. So our protection group technology, our protection group capabilities define the SLAs, the RPOs, the direction of the content that keep my sites in sync with each other. Those protection groups I showed you briefly over in this environment, on-prem, my applications, databases, and infrastructure, are now the ones of interest that I want to put in this plan. So I'm going to go ahead and pick those 3 protection groups, and in there are virtual machines. In there are all of the replication point in times that I have over time established between my 2 sites or 3 sites or whatever I'm looking at here.
Question on that. What's
Yes.
your lowest RPO?
Right now for the protection groups, we can get down to about 5-minute SLAs for snapshots. They're very lightweight, non-disruptive. We've got customers literally running thousands of those. So it's not synchronous, but it is very close to that. So think of your recovery points are being defined already through the capabilities of the DVX. Okay? I think these were set to an hour for a while, down to half an hour. I play around, moving them around depending on how much I want to, pay attention and generate.
Do I have bandwidth requirements to meet that?
Is
there a scaling factor that I need to keep?
So maybe I can take it over. For local snapshot, there is no bandwidth requirement. It's just metadata operation. You can snap 2,000 VMs in a millisecond. We don't move data. We don't copy data. So the file system is designed for it. There is zero impact on your running workloads on-prem. Now, there are bandwidth requirements if you want to replicate, obviously.
Yeah, so that's what I'm asking. What's
Right.
from my recovery point? Yeah, if I've got that down to 5 minutes for a
Right, so-
couple of thousand VMs, what do I need to replicate?
Right. So we've gotten to the point where we replicate absolute minimum. We have the technology called global deduplication. Since we control both endpoints, and the way the file system works, it's based on variable size blocks that are named with cryptographic hashes. When replication starts, the first stage is exchanging the hashes that I have versus destination. So we figure out what's missing on the destination. And then we replicate only what's missing in its native compressed form. So this is basically as little as possible, right? So depending on your churn rate, the RPO requirement is 5 minutes. Of course, if you're on a very fast network, 100, gigabit Ethernet and with high churn rate, you might not be able to satisfy this SLA for replication, especially if your outgoing pipe is, smaller. But that said, this is as good as it can get because we control file systems on both sides and we have deduplication. So you cannot beat that regardless of what products you use.
Yeah, the deduplication benefits really make that more aggressive but there is always a bandwidth requirement everywhere.
As long as I know what I need to provide.
Okay. So this is one of the key parts of the CloudShift plans. And so I'm going to pick those 3. The rest of this is kind of tying my 2 sites together. So remember my left and right-hand panels. All right. I built 2 different data centers, one on-prem and one in the cloud. And I want to basically tie those together at the vCenter level, at the folder level, at the compute resource level. I'm going to peek into one of these and just kind of look for a little bit more detail. So I have a couple of hosts on my on-prem, and I have just the single one in the cloud right now. This is a sort of a budgeting aspect and a preparation aspect. So I at least want one footprint there. So I've picked that. All right. The other thing I want to point out here is there's a little checkbox that often gets overlooked. Is when I'm building these plans, there is a requirement to fail over the real workload, but there's also a requirement to do regular checks and testing. So I can actually build different plans in the same, or different scenarios in the same plan for test and actual. For my environment, I kind of keep them the same, test them in a bubble if I can, or I let them come up like we saw earlier with the proper mappings. All of this sort of mapping back and forth, we're trying to take the complexity out of the things that are on both sides at that moment of a sort of disaster or shift of workload. Virtual networks get mapped across, and even down to IP addresses. So if we have IP mappings that have to be sorted out between one site and the other. Now, I'm not going to tell how somebody manages their environment, but there might be VPN requirements at one site, another different subnet. We provide the capabilities in here to map out either subnet or even specific IP mappings. All right, we're going to kind of go through that today for sake of time and just to kind of unravel all the details. But this is something that's built into the technology, into the plans. Additionally, if there are things that you have to do as part of a workload failover, either a pre or post task or a check or something that you want to have happen in that sequence of steps when the event occurs, we give you the ability to hang that in the environment. And then the key part here is the order of steps. All All right, now this can be as complex as you want. This is a relatively straightforward and simple plan. I want to make sure we can get through this and run live through this while we're talking. So this one basically is going to bring my infrastructure, protection group and virtual machines online, then my data stores, and then my applications. All right, so my virtual machines are sitting in that environment. It's fairly easy to rearrange this if I want to. And as I build these, I can decide what happens as each one comes online. And this is where I can hang in those special actions or deal with the virtual machines as that protection group is being restored for me. All right? The last piece of the plan here is how do you want to get notified if something is not going or the status of things. That continuous compliance check is always running. I may want to have a once a week report sent to me. All right? I may want to get an alert or an email whenever somebody's running one of the plans. All right? This is an administrator. I want to know what's going on behind the scenes. I have the capabilities of hanging that into one of these plans. I'm going to go ahead and close that so I don't keep a change I was clicking here. All right. Now, once the plan is constructed, I essentially have protection groups on one side replicated to a destination. My RPOs, my SLAs have been established. I've stitched together all of the pieces between my resources, my networks, my IP addresses, my folders. It should all map to the other side. That was homework that I did prior to coming here today. So organizing both of my sites only took a little bit of time to sort things out, but now I basically recorded them in my plan. Now what we're going to do now is actually begin failing over this plan. All right? Now that we've seen how they tie, this is going to bring in all that work that Boris had in his slide. Now, this is a little bit more than one click. It's actually 4 or 5 depending on how you want to count them. The first one is it's going to do a quick check. This is another fundamental aspect of CloudShift and what we think it enables administrators to take care of. Remember, I've got my protection groups. I've got different snapshot point in time, maybe every 5 minutes, maybe every hour. They're replicating to my target site. And if no replication is needed, I can restore those basically instantly at my target site. But I don't have to take the latest snapshot. By default, we pick that. But anything that was recorded as part of my protection group SLA and moved to my other location now becomes a potential recovery point for me. So let's say that the disaster was a cybercrime or a ransomware or a really bad administration action. And you really don't want to roll back your other site to something that you know is already broken at your original site. So you might roll down and pick something from an hour ago, a week ago. It's up to you. Part of this CloudShift action is picking the right recovery point for the destination. All right, I'm gonna let that sink in for a second. All right. The last thing here is how you want to deal with error handling. When we're doing a failover, this button comes up by default. It's ignore errors, push, run for the door kind of thing. We're doing a failover. If I was doing a test of this plan, I may want to stop if there's a problem. Go back and look at my assumptions. Go back and look at my setup. Fix some things, try again. All right, I'm going to go ahead and let this run. Real quick preview of the steps that are going to occur. All right, we'll see this in more detail in a couple of other places. And then finally, the last button. So let's go ahead and initiate the failover. All right, but before I do that, remember I had those screens split a little bit earlier? Give me one moment, I'm going to do that again. Slide this guy over here. And sorry for the resolution, but we're going down a notch. All right, on the left-hand side, I'm sitting in CloudShift. I'm actually not at my primary site anymore. I'm sitting outside the ecosystem looking down into my infrastructure. And what I want to do is fail that workload that I had defined here over to here. All right? Now I've created some folders here like applications, databases, infrastructure. It's real easy so I can map them through. It'll make it easier for you to see them too. But what I want to do now is actually execute this plan. All right? And we can sit here and watch these steps. What's going to happen are we're going to step through the plan, bring the protection groups back online, begin registering the VMs. I should see things begin to appear over here on my right-hand side relatively quickly. Let me open up the task window down here so you can kind of see the gory details. All right, so my first protection group has already come online. The virtual machines are being presented. It's looking at the plan, making any changes. It's going to power them on based on my power on rules in the plan. And in this case, I said, if they were powered on in the snapshot, bring them on at the remote site. I can have this set up however I want to so that I can have complete control over what's happening in the orchestration here. So now my virtual machines are literally coming online in the AWS cloud under the control of this CloudShift plan here that I put together basically as my DVX administrator and my VMware skills. All right? I'm going to stop there for a minute because this is where we just sort of sit back and watch. All right?
From a performance standpoint, so let me see if I'm getting the architecture correct. You've got S3 and you've got your cloud DVX, which is one machine that's using that S3 bucket to then present storage to the NFS VM that's on the
We want to go back to the
VMware
picture?
SDDC.
Yeah, let me take over.
And then that NFS VM has only so much bandwidth to present the storage for all the VMs that you're running. So how does this scale and perform in a big failover scenario?
Where do you want to go back?
Yeah, so it's the right time for the question. So at this point, as the plan is running, in that SDDC, there are two data stores, and we go back, we'll show. So there is our data store with backups, and there is vSAN data store, which is the destination data store.
What's presenting that first data store?
Right.
That NFS staging data store?
Right, we do. So we mount our data store via that virtual machine that we have deployed inside SDDC.
Okay.
So it's just runs the NFS protocol, NFS3 protocol. It doesn't.
But that's mounting S3 directly.
Yes.
Yeah.
So it does actually two things. It presents an NFS3 protocol. It does local caching, compression, deduplication inside SDDC. So there was a question about latencies. So depending on whether you're accessing cache data or not, for cache data you will see sub-millisecond latencies and tens of thousands of IOPS, because it's backed by NVMe flash inside SDDC. Now, of course, there's no magic. If you touch cold data, that is, in fact, an S3. For that access, you will initially see the S3 latency, which is what we observe is on the order of 20 milliseconds. So it's your SATA disk by factor of 2,
So I have a question on that. Have you tested that against the new instances that don't use local NVMe? Because the ones, the Elastic vSAN would not give you that performance.
It may not. So it's not available to us just yet. We've only tested it on the instances with local NVMe. Once you go to the Elastic ones, you will see 2 to 3 millisecond performance. That's correct.
Okay. And once I've moved that data out of your staging and the cloud DVS and DVX and into vSAN,
then let me just walk you through.
Sorry, no, I want to finish the question.
Yeah, sorry.
Once I've done that and I'm in vSAN, I no longer have your file system, I no longer have your snapshots or anything. So what's the benefit?
And how do I come back, more importantly?
Well, yeah.
Right. So we'll get to that point. Both great questions. So let me walk you through what happens for the first time of your question, and then we'll have a slide for the second part. Okay. So there's a lot of questions. So, okay, what is happening while I'm in this transient state? Yes, you have an NFS data store, but it is in fact backed by S3. How does it all work? So first of all, the orchestration starts, and the first thing it does, before we even get to that point, you have to restore from a snap and present it to that NFS, right? Because depending on which snapshot you choose, you may want to present a different version of your virtual machine, right? And this is the list that Mike has shown. Maybe you want to go a month back because you have a widespread cyber attack. So you present, and this operation is instantaneous. You just pick the snap, just present it to VMware. You register the VM, and you go through all these customization steps: IP address mapping, virtual network remapping, cluster, resource pool, all of that. So that's all mechanical. It's happening fairly fast, but we need to do the job there. And so after this all happens, VM is powered on, right? So at this stage, and this is what the questions are about. So I'm on, I'm running. This is fairly instant, as you have seen, but I'm not in my final state yet. And what is performance, and what are the parameters? Well, so the speed of light, you will bottom out at the bandwidth to S3, even though we try to amplify it by doing all data reduction while you're already inside SDDC, but still, if you get 400 to 500 megabytes a second, that's what you will see physically. Logically, you will probably see, depending on your workload, probably 3 times more. But this is what it is. Now, some accesses will be super fast. It's under a millisecond if you have local flash. If you don't have local flash, I believe you will see around 3 millisecond access. It's still not the end, not as good. If you hit something really cold, you will see spin-in disk latencies of S3. I mean, this is hybrid array in a way. It's a cloud hybrid array, but this is what it is. Now, we do all kinds of tricks, try to essentially move the data as fast as possible by trying to prefetch. Logically, there are two different workloads executing here. There is a user workload that does what it does, running a SQL database. And there is storage vMotion that we initiate, which is fairly predictable in a workload that streams the data more or less sequentially. And we have built some technology that allows you to run both. So satisfy the random workload, given the physical limitation of where you are, and yet at the same time try to prefetch in the background the data for storage. And I don't know if I answered your question, but basically what you will see is sub-millisecond latency for cache data. On the order of 20 millisecond latency, it's for S3 data. And as far as bandwidth, the cumulative bandwidth is the physical, we get close to the line speed, which is the CNI going up to S3. We are not going on the internet. This is just how, basically the handshake between AWS and VMware, this is what you get.
So is there an option to run multiple of those NFS data stores inside of the tenant?
Not right now. There will absolutely be, we'll need to scale it. But at the end of the day, you will still be limited by the outgoing bandwidth. Even with a single one, we come fairly close, right? But assuming that VMware and AWS have better networking soon, then yeah, we'll need more. Absolutely.
Where you spin up the workloads running on S3, and then you mentioned that there's the ability to migrate those workloads while they're running over to vSAN.
Yes.
That transfer rate, the amount that's going there, I imagine depending on the number of workloads you have, it could potentially reduce the performance even more. So is there an ability to control that?
Yeah, so we try to essentially penalize the storage vMotion part and give most of the available performance to the interactive transaction processing or whatever you run, right? We try to do it as much as we can. We don't expose any controls to end user yet. Okay. We will probably have to at some point. That being said, that storage vMotion probably finished. So it's all fully orchestrated today. So the end user doesn't need to know any of this is happening. But you will see. So what's working for us is that if you're in a disaster recovery case, so for those of you who guys have practical experience, you know that things, there'll be a period of time while, things are not quite there need to be, right? And it's not like, basically, if you need true zero RTO, you probably will be running a stretch cluster over a very expensive network. And it will be very expensive, but this will give you true RTO. It's a very expensive way to, TR is insurance, right? It's a very expensive insurance. You have 2 houses. Well, that's your insurance for, if the first one burns down. So this is a different solution where you only keep one house. You pay for your insurance. You'll get a very similar house, but you may stay in a hotel for a couple of days, right? As a flip side, you pay substantial amounts. So, and for most people, it means they can shut down their secondary data center, right? So that's the trade-off here. Let's see. And just before we finish this segment, so there is a lot of complexity there, as you have seen. Our customers don't see it, but it's a big distributed system. There's 2 clouds. There is on-prem. To make sense of it, we constantly run what we call compliance checks. And there's also the check marks that Mike has shown. Basically, we constantly do integrity checks of everything we create and touch. So before you run the plan, you kind of know if some of them are failing, the chance of success isn't very high. And we do it both on AWS side, this is just the source of replication, and on the VMware side, right? So even before you start the plan, so generally if everything is green, the plan will finish. If something is broken in between, you will know. You may have partial success, but you'll know ahead of time what part of the infrastructure, like VMware maybe do an upgrade, things happen in real life.
You saw the original one where the virtual machine came over and came to life almost instantly. All right, we did a little bit of moving around. The complete relocation into VMC has been completed. We now have a failover that we can commit. Let me just... Bear with me a second. Boom. All right, so I've essentially failed over my on-prem workloads. They're now running in these folders in SDDC, VMC in the cloud. This is my right-hand public cloud. If I come back over here, we can take a quick look at a couple of things. So that whole run is also captured. Think of it as a run book here. All right, I'm going to go ahead and take a look at the details of that. So take just a moment to create the PDF and pop it up on my screen. I know this is a little hard to read, but what I want to do is just kind of scroll through this quickly. This is an artifact now that shows my on-prem to cloud, DVX to VMC failover of those 3 protection groups that we talked about is mapped through, time of the run, all of the mapping that I laid out. So all of the hard work that I put in organizing both sites and creating a plan, now in the failover or in the test or whatever, I've got essentially a run book or articulating everything that happened, including all of the durations for the initial failover, the operations. Like I said, I don't expect you to read this. We could print one of these off if you want to take a harder look at it. But the key thing here is each of those protection groups as the virtual machines, I can see here that they are actually coming to life and what the implications are, the time and resources involved. So now I can use this as a documentation of what I just did. I could use it as an iteration on the plans that I'm putting together, as an evolution of my 2 different data centers. All right, all of that's done automatically for me. All right.
So maybe before the time runs out, one of the questions I still would like to see answered is the fallback piece. I'm really curious about, failing back into a data center. There's gonna be some magic going on there. I would like to see that.
This is our next segment. Thank you for asking the question. So this is actually something that people disregard. There are many commercial products that take it to the cloud, and this is where they end. And turns out coming back is equally important. The technologies involved are different.
Well, and given what you've done up until now, I'm just really curious how.
All right, let's do that. And then we can talk about it while it's happening and get into the details. If you look at the screen here, you'll see 3 green check marks. One of those was done at the very beginning of this session. One of them was just completed now. I did one a little bit earlier, sort of the magic of television. I had one that I wanted to make sure that we could fail back. So this failover here was essentially done before. Step 2 is to bring it back from the cloud back on-prem. All right, it's a couple of ways of doing that. I can pick literally any plan in here, duplicate the plan, and reverse the direction of what I was doing. So A to B becomes B to A. All right, and that's essentially what I did down here for these 2 plans. So if I pick this, I should check my typing. I'm going to fail back this one here and fail over from the cloud. Again, a couple of clicks. Much like executing the ordinary plan. Now we're going to do a planned failover. This one's a little bit different, and I'll type that R in. Okay. So what's happening here, and I'll kind of give you a quick look, and then we'll look at the details, come back and look at what's happening inside all these buttons here, because there are steps that are going to happen. But the plan is now running to bring a virtual machine or a workload back from the public cloud, back on site. Step 1 is already done. All right, and what that did was, over here, this is the failback demo. This little virtual machine here is going to come back home. All right, it's already been powered off.
And so is this still running on the
SDDC? Yeah. So,
but inside of your storage?
No, right now it's running on vSAN inside SDDC. Okay. And we'll see a technology slide there was another question about it. Clearly, we haven't given you a complete story and caught on this. There's magic happening right now, and we'll look at the magic.
Right. Can I just to clarify, because I'm interested to see that as well. I had a question there. When you clicked failover commit, that step, that's when you're moving off the NFS to the vSAN.
This is where we have already moved and everything completed. And at that point, you have an option of either staying there or rolling back. So you get the commit option only after storage remotion completes.
So actually part of the failover is, I don't get a choice. You move to NFS, and then as soon as you're mounted there, you move on to
Today,
vSAN.
you don't have a choice.
That's fine.
You will have many choices.
Yeah, but
today,
it becomes clearer in the next stage, I guess. But yeah,
yes.
That's just part of the failover to move you into the vSAN piece.
And you're in committed state where we are completely out of the way, except when you need to come back. And what's happening here, so basically at this point, you're completely running on vSAN, which is a completely different file system, right? NVMe flash or backed by EBS flash, regardless. So we need to come back, and we need to come back efficiently. We don't want to do a full storage remotion to on-prem using HCX, right? And also, us being a separate and smaller vendors in VMware, we don't have insights into how their file system works. But we have our own method. So what we do is, first of all, there's orchestration. So the VMs are powered off using exactly the same plan. You just reverse the direction. And this is an example of planned failover. When you're coming back, usually a scheduled event, you can do it overnight. You're not under pressure. You can take your time. So you power off the VM, and this is where the magic happens. Somehow we need to be efficient. You only need to take the changes. Say you were running in the state for a week on top of vSAN, and you need to take only what's changed. Now, so the good news is that most disasters, only 4% of disasters are due to hardware failures. About 50% is human error or cybercrime today. The rest of them is power failure, things that are correctable. 4% of the time there are hardware failures. The situation where you completely lose your data is an absolute minority. So most of the time, a week later, you restore connectivity, you put out the fires. Chances are you have local backups, you have something. You haven't lost the data completely, right? This is just a common case. So the goal here is to take what's changed while you're in the cloud, bring it back to on-prem, do it in the most efficient way possible. And this is where, so we had to develop technology that is, to some degree, similar to how sort of legacy backup was done in the past. So everything starts with a VMware snap. So you take a snap. They have what's called VADP APIs, so change block tracking APIs. What I didn't mention is that prior to failover, we also took a snapshot, and we remembered the handle. So you take a snapshot, you delete it immediately, so you don't slow down VMware. But it gives you the ability to ask VMware later, give me a list of sectors that have changed while I was in the cloud. And this is fully supported in your SDDC by VMC today. So you get a list of these changed blocks, and then you copy these sectors. And you copy these sectors onto that NFS data store is back in the picture now. And the way we create, basically the objective is take what's changed, convert it to our backup representation, and then use our normal, global deduplication way of bringing backups to on-prem. So we copy the sector into our data store. We create a Datrium snapshot in S3, the last cloud snapshot. We trigger it, and at that point, we are completely on our file system. We can use all the tools we've built over the years. We trigger the snapshot. Everything is activated. Your on-prem site is back on. Your VPN is back on. We use our normal replication path that will do cryptographic fingerprint exchanges, and global deduplication will kick in. We replicate everything on-prem, and from that point on, you essentially run the failover sequence that does your clustering map and all these virtualization abstraction. So from this point on, it's essentially our first and second demo. So that's the myth and magic. And if we go back to the demo, Failback should have finished by now, or at least finish it.
Yeah.
Yep.
You've seen me picking up my laptop. I'm just kind of watching the magic over here happen while Boris is on the slide. So those steps, we basically powered off the VM, synthesized the backup, took the snapshot, did the recovery, and brought it back and did some cleanup. If we look at the on-prem DVX, and let me just go full screen for just a second. Refresh. This is always the fun part when you're switching back and forth. I've been refreshing screens down here. Just give me a moment.
Do you have to power off the VM before you bring that back? Because if you've got quite a large snapshot, you've been there for a week.
Yeah.
Ideally, in some respects, you want to kind of do a couple on catch up and then sync that all the way back down. And then
yeah, so that's a good point. I'll tell you more. You probably want to back up your infrastructure while you're running on the cloud. So all of these extensions we are working on. So the ideal solution would, like, what would I want? I have my policies for data protection set up on-prem. Ideally, when I have a disaster, those same policies would apply exactly the same way in the cloud to exactly the same workloads, right? Because they're logical policies. If I want to have RPO of 10 minutes for this set of virtual machines, I probably want the same RPO in the cloud. Because remember, VMware creates as DDC, there is no data protection there. It's running in a single availability zone on AWS. If something happens, well, your data is gone. So the ideal solution would just apply exact same policies, continue doing backup, optimize the failover by taking multiple snaps. It's true that the impact is less because it's a planned event, but absolutely, if you have been there for a month, you don't want it to degenerate. So we are putting a lot of work into, implementing these features. Yes.
Yeah, so that virtual machine that was running in the cloud is now back on-prem. We can actually see that about 6 minutes ago, it received all of the data from CloudShift and then quickly restored the virtual machine locally. All right. So that's all part of it. And then back in the CloudShift, it failed back from cloud to on-prem. So I can go ahead and commit this. Back to the comment, what I'm basically doing is now a lot of steps happen in between, but I'm saying I'm happy with these results. I'm going to go ahead and commit this plan into my inventory.
can I just make one comment?
Absolutely.
A confirmation window that you're meant to type something and you can copy and paste into that kind of
defeats
the purpose of the confirmation.
We have
window.
our UX designer in the back. We'll work on that. Thank you.
You haven't seen me type.
It's also not very.
Yeah, I mean, I can understand for the demo, you don't want to have to type that every time. But like, if you're saying this is a seriously important thing, you need to type something and then allowing paste.
Yes.
Anyway, yeah.
Thank you.
I've actually got a way to. That could be the first action in the plan.
Sorry.
No, you could. So if you wanted to have some like secret code, so getting the plan started or committing the results, I'm doing some cutting and pasting in here. The first step in that plan could be a user action that does whatever authentication you want to do that we're not doing. Part of this is just ease of UI as well, right? All right. I think we're failed over.
Pretty much done. So
Lunch?
thank you for excellent questions. If you have more, go ahead.
We still have 3 minutes.
Yes.
So a couple of questions linked together. You're running the VMware Cloud SDDC for the customer.
Yes.
So you're kind of taking the charges for that and charging it as a service, or?
So that's a business question. So you could still, we are creating it. We are, like, the shape of it is how we want it to be. Whether the bill is passed through or not, it's a business question. We can support either.
That's fair enough. I just want to, and I understand you're kind of working through those pieces.
Right.
And leading on to that, there's a test option there.
Yes.
You know the size of the VM, what it looks like and things like that, and how many VMs I want to fail over.
Yes.
And because the VMware Cloud is a cost per minute service,
Right.
cost per hour,
Yeah.
is there an option to say, you're going to do this test, how much is this test going to cost? And do you want to do 1 VM or do you want to do 10 VMs?
Right. So it's a very, very good question. Yeah. It's not a simple question, as you know. The reason there is, ideally, yes, that would be, you would know it will cost me $10,000 to run my tests. So the reason it's not, there's a little bit of science behind it, is we do compression, deduplication, erasure code, and everything. Weissman does their own version of some of those optimizations. So we, ahead of time, and the way it's done today, the SDDC is generally limited by storage size. So they charge you per host per hour, but the number of servers is a function, usually how much storage you have. So it's a little bit of science to figure out how our data reduction compares to their data reduction. It is a great question. We could say, well, we know this plan will cost you $10,000 to run. Maybe one day we'll get into that.
But I guess if you left it on the NFS VM, because it's just a test, you might not want all the performance. At that point, you know all the data because it's still,
So perhaps next Cloudfield day, I understand your question, and we realize that is an issue. Perhaps next Cloudfield day, you will see a different kind of demo. By the way, for test failover, we do have an option of not doing storage of emotion today.
Yeah. Oh, okay.
So you could stay completely, because we know it's for testing, we'll have to tear everything down, so you don't pay for storage of emotion part already true. But you can also imagine the future where perhaps you don't need to do it ever.